morning. My name is Alex and I am an educator at the Emerald Coast Science Center. Today I'm going to be talking to you about adaptations and we're going to have a really fun activity to do towards the end. So before we begin, I just wanted to mention what an environment is to help better aid our understanding of adaptations. So an environment is a habitat or location where a species lives in. This is its surroundings, this is where it thrives and utilizes a shelter, a food source, a water source, and a space to continue its existence and a place to reproduce. So you might be wondering at this point what exactly an adaptation is. So an adaptation is defined as when an animal changes a characteristic about themselves that will allow them to survive better in the environment in which they live in. So adaptations can occur for a variety of reasons, but oftentimes it occurs as a result of a natural disaster or sudden change in the environment. If a natural disaster such as a hurricane or a tornado rips through the environment in which a species lives in, then a decision must be made by that species as to whether to stay in that environment and risk death, leave the area and find a new habitat to live in, or adapt to the new conditions presented by the environment in order to try and survive that area. So environments can also be changed slowly over time, and it will cause adaptations to occur in multiple generations of a species. So this is known as evolution. A classic example is shown by the melanistic or dark coloration of the peppered moth. The peppered moth increased in numbers following the Industrial Revolution as dark-colored moths appeared hidden against soot-darkened trees. The light-colored or gray moths that existed as well were heavily consumed by their predators. Typically, birds would be able to see them against these darkened trees when those trees were more covered in a white moss that are now soot and dust covered. So this caused the generation that had the darkened color to survive better and more quickly reproduce, whereas the light ones, they were picked off so they didn't have the opportunity to reproduce. So this caused a larger increase in that dark colored population. So when it comes to evolution and adaptations, one of the things is we have to try and consider whether an adaptation is actually evolution. It's necessary to identify whether it's also known in the ancestors and therefore may have evolved historically for a different function from those that it now serves. So evolution can occur as a result of adaptation, but it's important to be able to differentiate the two. It's important here to emphasize that adaptations are driven by the necessity to aid in the survival of a species and not simply by change itself without reason. Evolution can still occur due to change without reason. An example of this would be pandas. So pandas have a thumb that aids in eating bamboo, and while this trait aids in their survivability because it's allowing them to eat that source, the pandas have ancestors and relatives that do not have this thumb, and they do not eat bamboo. So that trait is considered an evolutionary trait and not an adaptation because that thumb is there while it benefits the panda now for eating. It wasn't created in order to help aid in survivability. So there are a few types of adaptation. There is structural adaptations, which are the change of a physical feature to adapt to a physical feature of the environment. So this would include camouflage, shape and size of body parts, a flattened structure in a species, different things like that, things that you can see with your eye physically. There's also behavioral adaptations that are changes in that affects the behavior of species and could be caused due to changes in the surrounding environment or the actions of another species. So this would be including change in reproductive strategy, feeding habits, migration, hibernation, or communication. A lot of animals will change the habits that they get into if they're in a routine where they get up during the day and sleep at night, but then all of a sudden they have a predator that comes in that has to alter their sleeping schedule. This is considered something like a behavioral adaptation. You also have physiological or functional adaptations. These are also physical adaptations but aren't necessarily seen in the species appearance. A body part changing in order to aid survival. We don't see that with our eye, but it is physically doing something to that animal's body. It could be within. So this would be how organs function, how digestive systems operate, or a good example would be a fish living in water that suddenly becomes more acidic, and that fish has to change its body chemistry in order to adapt, otherwise it could die. So why do some animals adapt? So animals adapt for a variety of reasons, but ultimately to survive. So some animals will do this to avoid being seen by predators. Others will do it in order to obtain food more efficiently. And there could be multiple reasons for adaptation. We have a couple species and a couple of great examples. So now I'm just going to go through several of those examples with you, and then we'll carry on to our activity. So let's go ahead and get into some of these examples. Have you ever wondered why sloths move so slow or grow algae and cyanobacteria on their bodies? It's so that predators don't notice their movements in the trees. That cyanobacteria and the algae actually are a greenish color, so it blends in with the trees really good. We also have lizards. Lizards drop their tails. So this isn't all species of lizards, only specific ones, but this is so that when a predator grabs them by their tail, they can drop it and keep running to escape that predator. It'll freak their predator out, and the predator will run the other way, or that's all that the predator gets to eat that time. Have you ever wondered why armadillos are covered in such a hard armored shell and roll into a ball when predators approach? So this is a protection mechanism. When the predator tries to bite down or use their claws to attack them, all they get is that really hard shell that's pretty difficult to penetrate. So those armadillos do have that hard armored body so that all their soft spots are protected, and that's why they roll into that ball. So as I said, some animals do adapt in order to obtain food more efficiently. So this includes hummingbirds. Hummingbirds have long, skinny beaks that help them drink their nectar deep inside of the flowers. This special adaptation, plus its ability to hover over flowers and fly backwards, make this hummingbird super specialized. Since it does use a food source that most other birds cannot get to, it doesn't need to compete with most other birds for food. Some bees and bugs might try to go for that nectar, but it's not fighting a huge population. Other birds have interesting beak adaptations that help them gather food as well. Pelicans have large pouch-like beaches to help scoop up fish and carry them away until they can land into a safe spot and eat that fish. Hogs have hook-like beaks that help them rip apart their prey, and that just helps them pull it apart. That way they can put it in their mouth and swallow it properly because they can't swallow an animal whole. In all of these cases, these special beaks help the animal survive. Some animals, such as giraffes, have more than one unique adaptation. A giraffe's long neck allows it to reach food sources in the Serengeti region of Africa that other land animals cannot reach. These giraffes also have very long tongues that reach 16 to 18 inches. They use their tongues as tools to pull leaves from branches. If you look carefully at the tip of a giraffe's tongue, the end is darker than the back. That protects the tongue from getting sunburnt. There's also animals called echidnas that are found in the deserts of Australia that also have unique adaptations. Their long noses help them locate food by sensing the electrical movements created by ants and termites. They then use their long tongues to get into those ant and termite mounds. They have large feet that are super powerful at digging. Those digging tools allow them to get into those termite mounds better, and they also use it to bury themselves underground to keep cool in that hot Australian sun. Some other examples of adaptations include a dog's sense of smell. A dog's sense of smell is 1,000,000 times more sensitive than humans, and this adaptation allows them to find their food and detect territorial markings from other dogs. Some dogs are trained to use their powerful sniffers to aid in search and rescue operations, so you might sometimes see that police use them for drug sniffing operations or missing people situations. You also have cats. Cats' eyes are adapted for nighttime hunting. You might see that sometimes they have eyes that get really large and round, and sometimes they turn into little slits, and this helps them focus more. Cats also have retractable claws that are used for climbing, hunting, and defending themselves, but if they want to crawl in your lap and cuddle, they can go ahead and put those away and be really cute. Strong lung muscles of deers help them run 30 miles per hour, so that speed is an adaptation that animals use to escape predators, and it helps them survive. You also have the leafy sea dragon, and these have evolved adaptations that allow them to blend in with their environment. So in this case, seaweed. And this avoids the attention of hungry predators that swim by, expecting to find them, and all they see is a lot of seaweed going by. The kangaroo rat in North American deserts is capable of meeting all of its water requirements by internal oxidation of fat. Water is a byproduct of this oxidation, and so it's really great when there is no water present. It can also concentrate its urine so that a minimal volume of water is used in order to get rid of all that pee and poop. A great example of biological adaptations in humans pertains to the people of Tibet. So the people of Tibet live in a high altitude. For most human beings, we can survive at high altitudes for a short amount of time due to our bodies raising our levels of hemoglobin. Hemoglobin is a protein that transports oxygen to the blood, and while this is beneficial when we do activities like climb mountains or go up high, our bodies cannot handle the continuously high levels of hemoglobin, and it becomes dangerous, so this makes long-term life at high altitudes dangerous for those who haven't adapted. Tibetans seem to have evolved genetic mutations that allow them to use the oxygen far more effectively without the need for hemoglobin, and therefore they are able to survive and thrive at altitudes where oxygen levels are up to 40% lower than at sea level. You also have aquatic animals. So mammals like to keep warm, right? They're warm-blooded. So you have animals like seals that need to keep all their body heat in as much as they can when they're in that cold weather. They're in cold water and surviving on ice. So they have a thick layer of fat or blubber that is below their skin that acts as an insulator in order to keep all of that body heat in. As I mentioned last week with Lucy, our red-tailed boa, these guys are often nocturnal, but they do come out during the day when the temperatures at night are really cold and they need to warm up by basking in direct sunlight. They are adapting and moving their sleep schedule so that they can make sure that they have the warmth that they require in order to survive. I also mentioned the tiger keelback snake. So these guys feed on venomous frogs and use that venom to concentrate poison in their throat that predators should be wary of. Females have been seen to prey solely on these venomous frogs during reproductive season, even if it means they have to travel further or search longer for this specific food, because they can pass on this poison to their babies that they reproduce. This adaptation is driven in their survivability in not only the individual, but in the increase in population sizes as well, because it gives the offspring a better chance at surviving. That adaptation allows them to change what they're eating and when they're eating to suit when reproductive season is. Mimicry is also a form of adaptation in which a species imitates another species or resembles the look of another being, such as plants or animals. A good example of this is a stick bug. So they commonly are referred to as walking sticks, and they began imitating plants as early as 126 million years ago. They look like sticks. Their twig-like appearance helps them defend against predators that hunt by sight. Camouflage is also a form of adaptation in which the coloration of a species changes to adapt to the background of their environment. The example that everyone thinks of when we talk about camouflage is chameleons. So chameleons can change their color very quickly to blend in with their background, not only to avoid predators, but to hunt. They can change their color to look like a tree branch or leaves and carefully wait for a bug to fly or crawl by, and they quickly spit out their long tongues to capture their prey and devour them. They can also change color to impress mates or intimidate potential rivals. Besides this, chameleons possess more adaptations than just the ability to camouflage, and they have several physical adaptations that help them survive. Their hooded heads help them collect water in the form of dew and also impress mates. They also have swiveling eyes that help them pinpoint fast-moving prey or see any oncoming predators. Their horizontal feet help them grip branches to keep from falling off and to hold against predators that may try to carry them off. So that's all the examples that I have. We're going to go ahead and get started on our activity. For this activity, you are going to need binder inserts, something transparent. You're going to need Sharpie and scissors. And so you can go online and you can find a pattern. I just freehanded my chameleon pattern onto my divider already. But you can freehand any animal you want. I chose to do a chameleon and a butterfly today just because these are typically species that you'll find utilizing that camouflage. However, you can cut out pictures of a dog, a cat, any kind of animal you want for this activity. We're just going to see how camouflage works. Make sure you're cutting carefully along those lines that you've traced. Again, you can use stencils as well, but none of your drawings have to be perfect. Mine definitely is not, but as you can see, we're just going to go ahead and cut carefully along those lines. Parents, if we have sharp scissors, you may need to step in and help out. So here's my chameleon. As I said, don't have to be perfect. I did cut a little swirl out, and I'm going to go ahead and use that and wrap it around my Sharpie marker. You can use anything like a bamboo skewer, a stick from outside, anything that he can hang on to, but that swirl and that tail is really going to help out by holding on. So now I'm just going to go ahead and freehand a butterfly. I'm just going to do a couple different shapes on here just to show you guys. You can do as many or as few as you want. So here's how both of my cutouts turned out, and you can kind of see them against different colors, how they blend in better over one or the other. So I recommend just comparing them if you do have multiple colors of the binder colors. They change color as they go against the background unless you have the clear. I also went ahead and I put these against different colored backgrounds. I just made a poster board of different colors so that you could see the differences. And so then I also made a clear one so that you can see how easily he changes color and adapts to that background. I also made a flower with each colored petal so you can just see the colors side by side as they change. Some blend in better than others, and that's the whole point of camouflage, is you have to find the right background in order to do this. So just go around your house, play with different patterns, different things, see how they blend in. Some might blend in better than others, but it's exciting to see what kind of patterns you can have. If you're looking for more activities based on adaptations, I recommend going back to April 2nd and checking out Cody's video about bird beaks, and you can see how different beaks are affected by different food sources. Check that out. So that's all I have for today. As always, thank you for tuning in. Unfortunately, we are still closed and we're hoping to open back up soon. But in the meantime, we're going to continue doing these videos for you all throughout the month of May. So hopefully you guys keep tuning in at 10 a.m. Monday through Friday. And we have some really fun lessons planned, some things that I'm sure you guys will be really intrigued to see. We do appreciate all of your support this time. Be sure to share these videos with friends and family back home. And I would love to see what your guys' favorite animal and their adaptation is, whether it's one that I mentioned today or one that you know about yourself or have done some research on. You could spend hours researching adaptations and animals, and I would really love to see what you guys come up with. So go ahead and comment on that or just let us know. But that's all I have. Thank you guys for tuning in. Hope you enjoyed this activity. You guys have a great day.